Hello everyone. In today's video we will be learning a simple concept of ranks, which is a small topic of the chapter permutation and combination. Since permutation and combination is a chapter where almost all the students fail to understand the concept, ranks is a much simpler concept where we could easily score marks if we get the idea of what we have to do. But the only chance of losing a mark here is only because of silly errors, that is of counting mistakes. Now I will start with an example, which is a three-lettered word RAT. Now the meaning of rank of a word is that, now if I have a question, find the rank of RAT in possible combinations of rat. What does this mean? I have the word rat here. We have to arrange all the possible combinations of this word in alphabetical orders. So RAT has three letters, which if we arrange in alphabetical order, we have A, then R, and then T. So starting with the first word, we take A, then R, and then T. Second, A will be the same, A will be the first letter, then T, and then R. This is just like a dictionary. Now the second letter, since all the possible cases where A was the first letter have been done, we will start with R as the first letter. Then as we have to go in the alphabetical order, so the second letter will be A, third will be T. Fourth is keeping the first constant, R, then T, then A. Fifth, since A and R is done, since the cases where A and R were the first letters have been completed, the third, that is R, will be the first letter T. Then since we are going alphabetically, A, R, and the sixth word will be T, R, A. Notice that this second one, fourth one, and sixth one do not make any sense, but this does not matter here. We have to list all the possible combinations of the letters of the word given to us, and we have to find the rank of the word rat. Now RAT was the third word that appeared when we arranged all the possible combinations of this word alphabetically. So the rank or the answer of this question is 3. Now what if I change the question to find the rank of RTA? Then the answer would be 4. Now here we got a basic idea of how the questions are asked. Now let's move on to the next word, that is marble, which is a comparatively bigger word. When we solved for the first question, where the word given to us was a 3-letter word, what if we have a much bigger word, that is marble, which has 6 letters, and the possible combinations of all the letters arranged in different types of words would be 6 factorial, which is 720. Here, since there were only 6 cases, we could count where the word TRA or where the word RTA was. But when the case arises where there are 6 factorial possible words that can be formed from this word, we have to apply permutation and combination here. Starting with the word marble, here we have 6 letters, and when we arrange this 6 letters alphabetically, we get A first, then B, E, B, C, D, E, F, G, H, I, J, K, L, M, and then R. So this is the alphabetical order. Now for the first word we have A. Obviously A would be the first letter of the first word. Then we have B. A, B, E, L, M, R will obviously be the first word of the dictionary that we are forming. Second, we have to go alphabetically. A, B, E, L would be the same. Only the last two letters of the word would be the last two places of the letters would be getting swapped. So the second word would be RM. Third word would be A, B, E. Now the first three letters would be the same, and in this alphabetical order, after L we have M. So the fourth letter would be M, and then we have to go alphabetically again. Since L and R are remaining, so first L and then R. For the fourth, A, B, E, M would be the same, swapping the last two places of the letters R and L. Fifth, A, B, E remains the same. All the possible cases where L and M were the fourth letter have been done, so R will come in the fourth place. Then we have to go alphabetically. L and M are remaining, so L, M, and sixth would be A, B, E, R, M, N. Now you get the point where we have to arrange all the letters alphabetically till the last word, that would be 7, is the reverse of the first word, that is R, M, L, E, B, A. So not 7, 720. Obviously I would not write each of the 720 words that are here. Now if we have to find the value of M, B, L, R, E, A, how would we find it here? It would obviously be a large number to count from the beginning. So is there any method to directly count it? Yes, there is. Here is where the idea of permutation and combination comes. The letters were A, B, E, then L, M, and R. It's correct. We have to find the rank of this word M, B, L, R, E, A. Obviously it would lie between the range 1 to 720 because that's how many number of words are possible from these letters. Let's observe the first letter, that is M. Before M we have 4 letters A, B, E, L, which have come in the alphabetical order here. Let's draw these 6 dashes which would represent the places of the letters. We have to find the rank of M, B, L, R, E, A. Since A comes before M, the first case would be where the first letter is A and all the other letters have arranged themselves in 5 places, so 5 factorial. So 5 factorial would be B, E, L, M, R, B, E, L, R, M, and all the other possible number of words where A was the first letter. So when A was the first letter, we have 5 factorial ways of representing these words. Now the second case where B is the first letter, obviously the number of dashes remains the same after the first letter, so number of words starting with B would also be 5 factorial. Third will also be the same, where L is the first letter and all the words starting with letter L would be 5 factorial. Now here the problem arises where M is the first letter. Now this is 5 factorial is 120, this is also 120, this is also 120. So we know that this word lies above, this word has the rank above 360. This is obvious. Now we know that M is the first letter M B L R E A. All the possible combinations where A, B and L were the first letter have been counted. Now when M is the first letter, when we go alphabetically, the second letter here, that is the 361st word, would be A, then B, then E, then L and then R. That is, we are going alphabetically. But we don't want A, we want B here. So if the counting the possible cases again, where this was for the first letter, now for the second letter. All the possible cases before B is the second letter would be A. Now this means MA and 4 more dashes. 4 more dashes means 4 factorial words. So this gives out 4 factorial, that is 24 words. Now after A we have B. So we also know that the rank of the word MBLREA is more than 360 plus 24, that is 384. Moving on to the second letter, that is all the possible combinations of MA have been done. So we know that 385th word till here was 384. So the 385th word would be MB, and then going on alphabetically, that is A is remaining, E is remaining, L is remaining and R is remaining. But we want the third letter as L. We know that MB is as it is, so we have to look for all the cases before L was the third letter. So before L is A and E, because B is already the second letter. So we will count for A being the third letter, starting for the third letter. When A is the third letter, we have 3 more cases here, leading to 3 factorial more words. That is 9. That is 6. Now M, B, E and 3 more letters, 3 factorial, which is 6. So these were the 2 cases. 6 plus 6 plus 384. That is 12 plus 384, 396. So 397th word we have is MBL, and then moving on alphabetically we have AER. But the fourth letter that we want is R. So again we look for all the possible letters that could come as the fourth letter before R. That will be A and E. For the fourth letter, we know that MBL is constant and we are looking for A. 2 more dashes, which would give out 2 factorial, that is 2 words. Second would be MBLE, 2 dashes, and would give 2 factorial is equal to 2 words. Now the 2 plus 2 would be 4, 4 plus 390, 4 plus 384 plus 12, 4, 384, 400. After calculating this, we have 4 plus 12 plus 384, that is 400. So the 401st word that we have is MBLRAE. Now all the possible combinations where A was the 5th letter have been completed here, because there is only one word where MBLRA, that is the first 5 letters of the word are constant. So it is obvious that the 6th letter would be the remaining letter from the possible options. So after A we have E, because that is the only letter remaining. So the 402nd word here would be MBLREA, and that was the word that we had to find. So the rank of the word MBLREA is 402 in all the possible combinations of the word marble. So we have completed rat and we have completed marble. Now these were the words where no letters were repeated, and obviously the questions won't be so easy when they appear in any exam. So the next video where we will be solving the questions to find the ranks of the word ball and Mississippi, and where the letters are repeating. Though the concept is same, there is still something to add on to it. So that's it for this video, and thank you.